We're now going to look at Q4, which has to do with improper integration. Now, some of these questions, like where I have the infinity, is quite easy to see it's improper, where the other ones, the bounds occur where we have discontinuities. So if I take the integral from 1 to 9 of 5 over x minus 1 to 1/3 dx, because I have a discontinuity at x equals 1, I have to take the limit as a approaches 1 from inside this bound. So this equals the limit as a approaches 1 from the positive of the integral of a to 9 of 5 over x to the minus 1 to the 1/3 dx. And to help with integration, I'm going to rewrite this as the limit as a approaches 1 from the positive, the integral of a to 9 of 5 x minus 1 to the 1 minus 1/3 dx. Well, this equals the limit as a approaches 1 from the positive of 5 x minus 1 to the 2/3 over 2/3 evaluated at x equals a to 9. And this equals the limit as a approaches 1 from the positive of 5 or 15 over 2, 9 minus 1 to the 2/3 minus 15 over 2, a minus 1 to the 2/3, which equals 15 over 2 times 4, or 8 to the 2/3, minus 15 over 2 times 0 to the 2/3. Now 8 to the 2/3, the cubed root of 8 is 2, squared is 4, so it's 15 over 2 times 4 minus, now 0 to the 2/3 is 0, times 15 over 2 is 0, so it equals 30. So we have an area of 30. In our next integral, the integral from 2 to infinity of 1 over x minus 1 to the 5/4 dx. This is a little bit more obvious because my bound is to infinity. So it's more straightforward to see that this is the limit as b approaches infinity of the integral 2 to b. And now I'm going to write this as x minus 1 to the minus 5/4 dx. This equals the limit as b approaches infinity of x minus 1 to the minus 1/4 over minus 1/4, evaluated at x equals 2 to b. So this equals the limit as b approaches infinity of minus 4 b minus 1, or minus 4 over b minus 1 to the 1/4 minus minus 4 over 2 minus 1 to the 1/4, which equals the limit as b approaches infinity of 4 over 1 to the 1/4 minus 4 over b minus 1 to the 1/4, which equals 4 divided by 1 minus 4 over infinity. Now, it'd be infinity minus 1 to 1/4, which equals 4 minus 4 over infinity to 1/4, or a really large number to the power 1/4, which equals 4 minus 4 over a really big number, which equals 4 minus 0, which equals 4. My area is 4. Now, for our last example of Q4, we have the integral from 3 to 5 of 1 over x minus 3. Now, this expression, 3 is my discontinuity, so I have to take the limit as a approaches 3 from the positive of the integral a to 5 of 1 and 1 over x minus 3. Now this here, this is going to equal the limit as a approaches 3 from the positive of ln absolute x minus 3 evaluated at x equals a to 5. So this equals the limit as a approaches 3 from the positive of ln 5 minus 3 minus ln absolute a minus 3. So this equals the limit as a approaches 3 of ln 2 minus ln of a minus 3. Now, ln of a minus 3, I like to just draw myself a quick ln curve that's adjusted by 3. So if I approach 3 from the positive, it's going to go to minus infinity. So this equals ln of 2 minus infinity, which equals ln of 2 plus infinity, which equals infinity. And I have an unbounded area, or a divergent integral. And for Q5, we're just going to write it below. Now, Q5, these substitutions look intimidating, but they're actually not too bad. So if we look at our first integral, the integral of 2x plus 1, x squared plus 4 to the power of 4 dx, it might be really tempting to just expand, but I encourage you, it's a lot of trial and error here. Just try to make one of them u. And if we let u equal x squared plus x, well, du by dx equals 2x plus 1, or 1 over 2x plus 1, du by dx equals 1. So this equals 2x plus 1 over 2x plus 1, x squared plus 4 to the 4, du by dx dx, which equals the integral of x squared plus 4 to the 4 du by dx dx, which equals the integral of u to the 4 du by dx dx, which equals u to the 5 over 5 plus c, which equals x squared plus x to the power 5 all over 5 plus c, which is nice. Now, if we look at our next integral, 2x minus 2 times cos x squared minus 2x dx. We let u equal x squared minus 2x. Well, du by dx equals 2x minus 2. 1 over 2x minus 2 du by dx equals 1. Subbing this in, we get 2x minus 2 over 2x minus 2 times cos x squared minus 2x u by dx dx. These cancel again, giving us the integral of cos of u du by dx dx, which equals sine of u plus c, which equals sine, remember we have to substitute back, sine of x squared minus 2x plus c. I'm going to leave the last one as an example for you to work through, but you'll see it's not so bad. There's a factoring trick that you need to do with this last one.